found this one. Yeah, we're good.
Good. I was thinking I'm gonna get a coffee then.
We're just about to start. So,
Yeah, let me just make sure that these slides are
I understand the priority.
showing up inside.
I'll go and get the note well on the screen.
Oh, take. You're gonna do that.
I'm gonna do that.
I'll do all the others.
If I can figure it out. I'm gonna share that. You sharing it?
No, I was just trying to see because these ones are not yet in Medica.
Okay. Let's see if that works.
Back just to see. Oops.
Okay, folks. Ooh, we really need to eat the mic this time. Okay. We're going to get started in just a second. You good? Okay. Okay, well, welcome everyone. This is the second session of HTTP. It's later in the week, so hopefully you got some coffee outside. Let's get into it. First off, as always, this, as you see on the screen, if you can read it, is the note well. If you're not familiar with this, take a look on your favorite search engine for Ietf Note Well, and you'll find it. It's the terms and conditions that we participate here under, which are very important to us. It's important that you understand this. It covers things like competition law. Believe it or not, standards organizations, one of the primary reasons is just to allow competitors to talk to each other. So understanding this is really to your benefit. It's also handling things like behavior, making sure that we don't treat each other badly. And so have a look at it if you're not familiar with it. We take these things seriously. And if you have any questions, please feel free to talk to Tommy or I or any other leadership folks. Our agenda for today. There we go. So we need someone to take notes. Do we have any volunteers? We really do need to have a record of what we do here for our own purposes as well as aforementioned legal purposes. Eric, that's fantastic. If folks can give him a hand while he's at the mic, thank you so much, and thank you, Ted, as well. The blue sheets are now automatic. You need to scan these QR codes that you see plastered all over everywhere to note your attendance here. And also, if you want to speak at the microphone or remotely, this is how we know that you want to speak. So please do sign in on those with your data tracker account. Today, we have a pretty packed agenda. We've got 2 hours. We're gonna have templated connect TCP. And then another presentation from Ben, security considerations for optimal use of HTTP upgrade. Then I'm going to talk briefly about retrofit structured fields and then cache groups. And then Patrick is going to talk about compression dictionary transport. Those are all active drafts, things that we've adopted and we're working on. After that, we've got some other presentations about things that the working group is not working on, including HTTP 3 on streams from Kazuho. Sorry, Kazuho, we don't have your name on that one, but that's also from Kazuho, I believe. And reverse HTTP tunnels. The first one of those is had some discussion earlier in Quick, and now we're talking about the HTTP part of it. Then we're going to talk about window sizing for Z standard content encoding, and finally, some discussion about best practices for linked local connectivity in URI-based protocols. Any agenda bashing? All right, let's get right into it then. Ben, template to connect TCP. Are you out there? Yes, you are. Great. I'll give up the presentation. I'm sharing. You should be right.
Great. Okay. Packed a short time window. Let's get started. So, quick reminder: this is the thing we're talking about. It's this thing that's like Connect, but more like the mask style. It involves some kind of URI template. So when you are saying, I want a TCP socket to this host and port, that information goes in the query parameters. And in HTTP2 and HTTP3, this is extended connect, but in HTTP 1.1, there's some kind of tricky use of upgrade, which is exactly the same as mask. So since the last time we talked about this here, there has been a new draft with a bunch of changes. So we added some people asked for a default template. So we added that with some text that says you only use the default template if plain connect fails. So like you try to use good old-fashioned connect, but if that is failing in a suspicious way, you can try using this with the default template instead. We settled on www authenticate as the relevant authentication header for this purpose. And relatedly, there's some text now about the fact that HTTP connect proxies don't exactly have a clear origin, but templated TCP proxies have an unambiguous origin, and so all the origin scoped headers apply as usual. And we added a security considerations section. Okay. So this document started a working group last call, and there were a flurry of issues. Thank you for everybody for actually reading the draft in last call. Some of those were editorial issues or other things we were able to quickly reach agreement on and clean up, but there are 3 issues that I want to talk about right now. First one, TCP port. So draft 02 says that you can take all these different kinds of template-driven things that we now have, TCP proxies, UDP proxies, IP proxies, and more other stuff, and you can just kind of squish it all together into one big template, and then just by looking at the template, you can see what it supports. You can see from the variables. It turns out there are a couple of problems with this. One is that the connect IP specification doesn't actually require the proxy to support any of the variables. Literally, any bare URI is potentially a connect IP proxy if you don't have any information. So, so you can't derive that information from the string itself. And also, sort of more abstractly, nothing in any of these specifications exactly forbids you to say like, oh, I just decided to put in an IP proto parameter into my URI template, but that's not because I support connect IP. I just felt like putting an IP proto variable there, which seems really weird to me, but anyway, it's not explicitly forbidden. So there was a proposed change here, which is to say, forget about all this. Instead of using TCP port, which makes this support for connect TCP uniquely identifiable, just use target port the same as mask, UDP. And then that means if you're a client and you get one of these things and you don't know exactly what it supports, then you would have to either probe it or you would have to know somehow out of band. And so that's the proposed text there for this change. The alternative to this, I think, would be to define this concept of a multi-protocol proxy template in an explicit way, probably create an IANA registry for like the things that can be part of such a multi-protocol template and the variables that identify it. Tommy?
Hi. So just speaking purely as an individual from right here, as you're aware, we have the discussion and the document recently adopted in int area for discovering, essentially like getting a JSON file of the configuration of the different proxies you support. And so that is one way to disambiguate things, because like if you get a proxy URL, then you're like, I don't know what this is. You could always ask it for that file and say, my connect IP URI is this, and my connect UDP URI is that, and then that would help tell you. So I'm not suggesting that we point to that from this document, but overall, that is a solution space, like the separate usage indication. So we have
my understanding is that that's limited to provisioning domains.
But technically so the document within int area is saying that every proxy has its implicit own provisioning domain. You just ask it for a particular well-known URI, the well-known PVD, and then it can tell you what proxies specific protocols it has. Anyway, we can take that separately.
Okay. So, yeah. So I'm personally neutral on this on this question. I would like us, right now, I think probing is pretty ugly. I really find this quite unfortunate. The usage indication that you have to access via the proxy is also a little weird. Like, I have a proxy, but I don't actually know what protocols it supports. Let's hope it supports TCP and try to use it over TCP to fetch something to find out. I don't know. But anyway, so that's seeking input on that. Let's move on. Okay, another topic that was discussed on the list is the question of happy eyeballs and target host lists. So in draft 02, the proposal tries to do a little bit better for happy eyeballs than Classic Connect. Classic Connect says you can choose a host or an IP address. But then if you want to do happy eyeballs, you have to make multiple independent connect requests for these different families. You have to essentially drive happy eyeballs all the way from the client side if you want to do this. There's basically a lot of overhead. You're setting up and then tearing down entire unnecessary TCP connections much of the time in a way that would not happen with normal happy eyeballs. And also the same thing applies even in the absence of happy eyeballs to just multi-IP failover. DNS resolution normally returns a collection of IP addresses, and if one of those is down, you expect your TCP client to basically transparently fail over between them. And all of that logic has to be driven from the client side, unless we can pass lists to the server. And so that's what draft 02 and prior drafts in this line propose. But there was some concern that this is too complicated. And so there was a proposal to drop this feature and add it as an extension. But we don't have an extension mechanism. So I have no idea how to add it as an extension. Except maybe, again, through some kind of probing, but I really don't even know how to do the probing. It's pretty... So it's not clear to me how that would work. So my preferred alternative is to keep this in. I don't think it's that hard to implement on the server. And one thing we can do compared to draft 02 is to simplify the syntax. So it's just a comma-separated list of IPs. And we only need level 3 templates. We don't need level 4 URI templates, which are a little more complicated.
Hi, so again, as an individual, I'm just going to have a lot of opinions here. I apologize. I'm definitely in the camp of dropping this from it. As far as I know, this is not something anyone has a lot of experience with. And I would like to see any mechanisms we have here be parallel across the various proxy methods. As you point out, Connect UDP might not work with happy eyeballs in all cases, but we also have variants that are aware of quick. And like, I definitely have done happy eyeballs with UDP. It definitely can work. There's a chance that we may be having a happy eyeballs related working group spinning up that this could totally be discussed in. So I would go for dropping the feature. And then as far as extensions, we do have the ability to add other headers. And as we'll talk about in the next slide, there's possibilities for using capsules here. And I'd like to find a generic solution that would work not just for Connect TCP.
Okay, I don't actually think you can do this with capsules, but we can talk about that sometime later. Eric?
Eric Kinnear, yeah, hello. Just a note that when we're talking about happy eyeballs and UDP and all that stuff, like I think the text that says treat it as if you got it back from an A or a quad A query works equally well for UDP. And if that doesn't give you a massive level of excitement because you're not doing quick, then that's the same as if you just made a regular DNS query. So like, I don't think we should over rotate on that. I think we should focus on, can we make this consistent across all the different places?
Okay, Jonathan?
Jonathan Hoden, Cloudflare. I haven't followed this at all, but just why can't you, in this case, send a URL to the server and let it handle happy eyeballs, DNS, TCP, UDP, like everything?
Yes, you can pass, in this case, it would be a host name to the server, which it will resolve, and then yes, and that is uncontroversial. That is the same as connect. The question is, if for some reason the client needs to do its own DNS resolution, or IP addresses aren't coming through DNS, can you give the server exactly that same information that it would have gotten through DNS resolution? Can you effectively say, I'm the client, I did the DNS resolution, here's the answer, do whatever you would have done if you'd done it yourself? Because DNS resolution produces a collection of IP addresses.
A collection of IPs. Thank you.
Okay. We're out of time, so I will, I'll leave it to the chairs to decide, but so there's also a proposal to use capsules. My preference is to say that this can be done at a later date if needed. There's, as far as I can tell, no advantage to declaring that we're doing this right now.
Sorry, just jumping in very quickly here. My main, I'm okay with leaving it for a later thing, although I would like to do that like quickly, and I'm happy to work on that. But I'm concerned that if we do not mention the capsule protocol at all, that we could have implementations that set it and have a different interpretation. So we may want to like prohibit the use of it until you have it defined somewhere else, because we don't want people to just say like, hey, I had my connected UDP, I'm going to say capsule protocol over here, and now they actually don't do it correctly.
Okay, I think that's totally reasonable.
Tommy, if we don't tell people that it's a capsule protocol, then it's not. And then you've effectively prohibited that anyway. I think that's the default.
It is the
You're
default.
also-
But we can put in a
what is the
non-normative.
behavior?
We can
You're
put in a
also-
non-normative reminder about that.
Yeah, I wouldn't bother. We're also not transporting elephants. We're transporting bytes. And that should be clear.
David Skenazy, one of the two capsule enthusiasts in the room. Lucas just walked in, Ben. So I think it could be cool to use capsule for this, but I don't think the maybe use capsule is viable at all. In particular, when we designed the capsule protocol header, we always decided that it meant nothing. It is not, you don't have to send it, which is a decision I wasn't happy with, but that's what the consensus was. And so you can't use it for any kind of negotiation, unfortunately. So I think our only two options here are either to say this doesn't use capsules, and it's kind of like regular connect, or it uses capsules all the time, and we introduce a data capsule. Or you can negotiate with another header. That's right. Okay. That was from Martin Thompson. I lean towards maybe making this capsule. That's what we're doing with the new things. Having implemented capsule parsers, like it's trivial, but I don't feel too strongly. I just don't want us to negotiate with this.
Yeah.
Mike Bishop, two comments here. First off, do we actually have a use case for capsules with this? Because if we don't and we can't envision one, then let's not build it until we do. And second off, Martin, I admire your optimism that you were able to go all the way through the quick drafts without giving up on the we shouldn't say the obvious. We said a lot of obvious stuff in there.
Okay, we're having great discussion, but we are over time on this draft, so it sounds like we still need a little bit of maybe on-list discussion, confirm those things, and a new draft, Ben?
Yeah.
Okay, thanks for that. So you're also next. Do we want to go ahead and switch to that one?
Okay. So sort of related, but this is about HTTP upgrade, HTTP 1.1 upgrade in general. This is a recently adopted draft. It has no changes yet from the pre-adoption text, but there are some proposed changes and some topics that have been discussed that are worth mentioning. So The current draft only makes recommendations to standards authors. It says if you are defining a new upgrade token, here are some things that you should keep in mind. In practice, those recommendations to standards authors in turn are things that they should probably tell clients to do, mostly. But there's a proposal that actually maybe this draft could tell something directly to server implementers right now of existing tokens. And the proposal is if there's a failed upgrade, so if you have a request with an upgrade header and you don't accept the upgrade, then you should close the connection, I guess, after replying with a non-upgraded response. And this prevents, and also crucially, before reading the next request on that socket. So this prevents basically the whole category of issues that are being discussed here, and it's compatible with any existing upgrade token. So very cool suggestion, but it does slow down basically anything that has an upgrade, reject, retry sequence. And that's actually a pretty common sequence for anything that uses HTTP authentication. Maybe I'll just charge ahead. Another suggestion that came up was to say upgrade tokens should never have a body. It's a little unclear. This is my best interpretation of what this suggestion is about. I think it's really about gateways, saying like before you talk to that backend server, if you got an upgrade header and a body, then you can just drop that upgrade header. And there were some concerns about basically confused backends here, but also this would be incompatible with some of the like weirder long tail sort of unimplemented existing uses of upgrade and potentially future creative uses of upgrade. Okay, and the third thing that I wanted to talk about was status of upgrade HTTP 2.0. The bottom line here is it seems like this is not actually a thing, but the documents aren't very clear about it. And I think we should probably delete it from the IANA registry. And while we're at it, we should probably also delete upgrade TLS, which is also like ostensibly defined, but not actually a thing. Okay, question.
It's not a direct question about this, so I can let you get to the end of the slides unless you're already done.
That's the end of the slides.
Okay. So I know this is focused on Connect, but I had a case. I was speaking to someone who was seeing like an issue on this for just a plain old, I'll make a H1 request to a server that I can fail to connect to, and then what do I do? Do I accept the remainder of the incoming client stream to like dispatch more requests? And their answer was no, I'm just going to close the connection because I can't, like this whole thing is completely blown. So yeah, it wasn't an upgrade. It was literally a post or whatever. Like is that already covered in the HTTP specs or not?
So wait, it was malformed?
No, it was like you would make a request to a reverse proxy and it would try to pass that to one of its configured upstreams, which wasn't there. When it would return a server error, but then it couldn't safely process the remainder of anything on that connection. So the safest thing was just because we would maybe read the post request body as the next request to be made and forward that somewhere.
That should be unambiguous from the gateway's perspective.
Maybe, I don't know. I haven't had
the
enough
gateway.
coffee.
I believe a gateway can like read and process an entire post request on its own.
I'd love to talk to you about that after the session, maybe.
Yeah, I think in this case I had like no content length, and it was too risky. So the safest thing was just fail.
Oh, if there's no message to limit, yeah, we can point to parts of the spec. Okay.
Sorry to confuse this. It sprung to mind as we were talking to this, and it happened like in the last 2 weeks. So thanks.
Okay, Ben, did you have anything else in that spec?
Those are the only issues I wanted to mention. So, I'd like to get some more input about these topics so that I know what to do with the next iteration of this draft. So please engage.
Great. Thank you very much, Ben. Any more comments on that? Okay. I feel like I have to really close to this mic. No, that's better. Okay. Wow. Okay. Next up, I've got retrofit and then cache groups. Both should be very brief. Let me try to share a screen here. No, not share slides. Oh, I need to stay here though, so I'll just hello. Is it?
Yes, we know what wireless means.
Good evening. Okay, we've got this one up, and I will make it more legible. So first of all, retrofit structured fields. This spec we have been lightly parking for a little while we got Sfbis done. Excuse me. And Sfbis is almost done. It's in final ISG stages. So we're going to return back to this. And for me, there are a few issues here to work through, which I won't go through today. But the thing that caused us to park it was that this is a very abstract specification. It's talking about how you might take existing HTTP fields and map them into structured fields. And we don't, we have use cases in mind, but they're not in this spec. And I think that there's a little discomfort that we're not entirely sure what the sharp edges are on these things until we use them in anger. So I'm starting to think about how we can do that and get some experience with these before we actually publish it. So if anybody wants to talk about that in the background, I'm very happy to do so. But this is really just a status update that we're going to start trying to get this one moving again now that Sfbis is done. And any discussion, comment on this draft? Otherwise, we can move on. Martin.
Yeah, I'm kind of curious as to whether you have any thoughts about what getting moving looks like.
Firm thoughts? No. Half-baked thoughts? We can talk all day.
All right.
Yeah.
Okay. Yeah. So thinking then.
Yes.
Wonderful.
We're still in the thinking phase. Yeah. And you know, when I talk to people about this spec, I think a lot of people nod their heads and say, yes, that is a very intuitive, natural, and wonderful thing to do potentially. But we have to get it right if we're going to do it. And that's the tricky part here. And for the record, Martin Thompson is nodding. So unless there's more discussion on that, I'll just move on to cache groups. So cache groups, this is a specification to standardize what is a fairly common behavior, at least in intermediary caches, which is allowing the origin server to tag different responses to tie them together so that you can do things like invalidate them together as a group. And that turns out to be a very useful thing to do for the origin server or for the resources on it. And this is a fairly straightforward spec because there is implementation experience with the concept. I think my issues right now are two things. One, what the details of required support are in terms of how many labels should you support for each response and so forth and so on. And I did a little digging around the documentation of the folks who have implemented this, at least the CDNs, and they seem to converge reasonably well. So there's a proposal in there. Take a look at it. I'll probably write some text for this pretty soon. And the other was that there's a very thought experiment-y kind of feature in the draft, which is if you group a bunch of resources, or sorry, representations in a cache, and one of them is revalidated, it might be interesting to assume that all the other stored responses in the cache with that group are also revalidated at that same time. So they kind of go together as a flight. And that has some very interesting properties, but it's also extremely speculative. So I'm thinking of dropping this from the specification because we don't really have any implementation experience with this at all, or any measure of demand. It's just really interesting to think about. But that kind of says to me, well, maybe we need to make sure that we have an extension mechanism so that future uses like this can be lumped onto cache groups. And so I want to think about that a little bit. Other than those two issues, I think this spec is almost ready for working group last call. So if folks have any comments or thoughts, I have talked to various different implementers about this. There is some interest in this. I think they're just waiting for the spec to settle down.
Do you want to change the name of the specification if you're not going to do the revalidation thing?
See David's discussion of bike shedding on Tuesday. The current name is a little bit of a compromise because the different vendors call this different things, and I didn't want to favor any one vendor. So with that constraint in mind, I'm open to new names.
Yeah, I mean, if the sole purpose of it now, at least, is invalidation, then that might be something that you could work in there. Just so it's clear. I think there's...
To be honest, no vendor currently refers to invalidation in the name of the on the wire artifact. It's always something like, here's a tag, or here's a,
Sure.
And that it seems intuitive to the user. So, yeah. But here we're talking about names. I'm very happy to be talking about names on this draft. Any other feedback? Otherwise, we can steal some time. Okay, let's move. So next up, we have compression dictionary transport. Patrick, are you there? You are. Fantastic.
Yes.
I'll start sharing.
All right, and Patrick, do you want to share your own slides? You can click the share. You can click the share slides button, and I can grant you permission. Okay, here we go.
Alrighty. So quick update. Brief overview for anyone not aware of the compression dictionaries. Allows for negotiating any HTTP response to be used as a compression dictionary for content encoding for future fetches or future requests. There's an HTML bit that allows for side loading of dictionaries if they weren't going to be fetched as normal part of operation. That's not part of this spec. Then at some point in the time later, browsers advertise the available dictionary they have that best matches the request they are about to make, and as well as the encodings that it supports. And they can tag the dictionaries now with an ID. And the server, if it chooses to use the dictionary, specifies which dictionary it used and what content encoding it chose to use. Updates, Chrome 123, which is rolling out literally as we speak, has all of the changes in draft 3 in a new origin trial for compression dictionary transport v2. The original origin trial that we were running up until this release was pre-Httpbis adoption, so there's a fair number of changes that are included in the current origin trial. We're hopeful that this is the last origin trial to sort of get our feet wet and make sure it's actually working the way we think people want to use it. And there is a new draft that was sent out just shortly before things got locked down. There are 2 bits that are sort of tangential to the Ietf side of things that are WhatWG specific. The HTML tag that I mentioned for fetching or triggering a fetch of a dictionary needs to get added to the HTML spec, and the fetch integration with the core's processing model of browsers just needs to be flushed out in the fetch spec for WhatWG. But the core of the protocol and everything else is owned by the Ietf side of things. And the explainer and everything else will be moved over shortly. The changes that have been done in the 03 draft since the previous time we talked, the server now has to send a content dictionary response header with the hash of the dictionary it actually used, rather than just assuming a match with the request header, the advertised dictionary from the client. So now it's more explicit. The dictionary hashes are now binary or byte stream, so basically base 64 encoded instead of a hex string. Dictionary-specific time to lives have been removed, and now it just uses the resource expiration time plus stale while revalidate time of the dictionary resource itself as the time that the dictionary is valid to be used as a dictionary for. Match, instead of its own custom wildcard pattern matching thing, is now a URL pattern. The match destination, match dest, is now a list, so you can match document plus script plus style plus iframe if you want, as far as fetch or request destinations. And there is now an ID that if the dictionary response includes an ID with it, it will be echoed as specified, as sent in future requests where that dictionary is being used. So intermediaries or the origin can key off of the ID instead of having to look it up by dictionary hash. The open issues that were live at the time that the slides got locked in, kind of an old one, or these are all fairly old. Question if we should split it into 2 documents. I think enough has been changing in all parts of the document that it's probably best to just keep it as one document and just keep running it as experimental until we're sure it's the way we want it to be. It's flexible enough that I don't think that'll lock us into anything that we can't add to later if we wanted to. There's some concern about the match pattern allowing for users to specify an origin, even though the origin must be same origin as the request. Unfortunately, URL pattern doesn't have a string-based constructor that allows for excluding or not allowing origins to be included. They don't have to be there. It's encouraged that they not be there because it's a waste of bytes, but we don't have an enforcement mechanism to prevent it. And then there's just a placeholder to make sure the ZSDCH stuff that the Edge team rolled out, that's Bing Microsoft Edge specific, that their use cases are met with the compression dictionary work. And we've been talking to the team, and so far it looks like it, but I've been keeping this placeholder open until ZSDCH can be rolled back and unshipped. And then there were a few issues that came since that are probably more interesting. So there's a request that we specify a single compression algorithm instead of allowing both Z standard and Brotli, so that for adoption reasons, we don't have to have clients implementing everything if they want to be able to support arbitrary origins. Then that will lead to some question about which algorithm, which feels like it's going to be an interesting discussion, but there are benefits to both. The issue is in the repository, so we can discuss it there. We need to be explicit about the window sizes that we support for the compression algorithms that we do take up. Nidhi will be here talking later about the Z standard stuff that's specific to Z standard encoding that's not dictionary inclusive. The dictionaries have a special sort of edge case that for Z standard, at least, the compression windows need to be larger than the size of the dictionary. Otherwise, by the time they treat the dictionary as sort of a precursor as part of the compression window. And if the compression window is not larger than the dictionary, there's a good chance you actually won't be able to do delta encoding. And so if we support Z standard for dictionary compression, we need to support fairly large compression windows, probably on the order of 128 megabytes, which is what the default for the CLI is for Z standard. Brotli, I don't believe, has the same issue. The dictionary is always available to the compressor and decompressor and still works with the 16 meg default window. And then the final sort of open question is if the match pattern should be a single pattern or if we should allow for a list of match patterns to allow for a dictionary to perhaps reference like a script location as well as itself as separate patterns, so it can be used as a dictionary to upgrade itself in some edge cases. It feels like that's something we can probably extend later, but it's worth discussing. And the dictionary matching requires a linear search through all of the available dictionaries anyway, because there's no way to hash look up a pattern. And so adding it as a list doesn't really change that. Some other questions. When we changed the origin trial in Chrome to move to the latest spec, there has been some pushback about moving to the byte stream format for the available dictionary hashes. I don't know that it's a deal breaker. It's just there has been some developer friction of using the base 64 hashes instead of hex strings just because they're not file system safe. That said, people probably want to be doing more processing to make sure that the URLs and hashes are safe rather than just mapping them directly to the file system. So the added processing step might be a good thing to make them be more intentional about it. And that was all of the updates and questions I had.
Great, thank you, Patrick. Oh, it's like that one now. Great, thank you, Patrick. Any discussion, any questions on this spec? It's great to see progress here. I think everyone's very excited about this one. I will say the origin trial feedback we've gotten so far has all been very, very positive, with some fairly large savings being seen in production for at least like a JavaScript use case that I know of. Awesome. Lucas.
Yeah, just a thought on the last point, the byte string versus hex string stuff. Like, who's using file systems now these days with like cloud object storage? Like, I don't know anything about this stuff. So just a really.
So it's more that what could have been done before is the request header of the available dictionary could have been tacked on directly onto the URL and tried as a request, basically using edge functions that are already available. And then if the origin just added the hash to the end of the file name, it would just work with minimal processing, even for objects stored in the cloud, for example.
I just wonder how often it is that a server receiving requests for a path has to go through a bunch of remapping into whatever their object storage IDs are. I have no understanding, but maybe that's just a really easy operation that people already are doing. Just throwing it
I mean, it's fundamentally very similar to storing .gz files for pre-gzipped files, right? In this case, it would just be .hash. Martin.
So I know this is not an implementation deployment report, but I'm very curious about the split between the use of this for deltas and the use of this for, I have an arbitrary dictionary that's going to match a bunch of resources and I'm going to use it there. The use as dictionary case, because I see the former being relatively straightforward to implement and the latter as being far more complex. This is the matching stuff. And when you said, oh, you have to do a linear search through all the patterns in order to find something, that rang alarm bells for me. I don't know how scalable this will end up being.
On the client side, it has to do the linear search. So if you're not using match dest for destination matching for like document or script or whatever, and let's say you just have match all requests, and then you have 10 dictionaries on an origin, for example, each one would have their own pattern. There's no way, given a request, to have a lookup for patterns without looking through each pattern, for example, right? And so you're kind of limited to the global number of patterns that you're going to have on an origin, that the more that you add when you get into like, if you have thousands of dictionaries on a given origin and you're having to do a linear search across all thousands, that could start to become a problem.
Do you have a solution for that problem? Because that sounds like a real problem.
Not really. I mean, you could probably do things on the client side to optimize if you have prefixes for all of the paths and the paths are all relative, and your patterns, you could do something a little faster, but given it's very similar to the service worker sort of pattern matching, where if you allow arbitrary patterns and it's not just a prefix, it's hard to be more optimal than that.
Okay, I think
And it applies to both the delta compression and the dynamic case, because both need to run the pattern matching, because even the delta compression, it's one URL to a different URL.
Okay. Well, we probably need to talk about this a little bit, because that sounds like kind of a denial of service vector to me.
I mean, as far as the denial of service vector, it would be an origin denial of servicing itself, because only an origin can set dictionaries for that origin. That said, a given origin can have thousands of product teams that don't talk to each other.
The client's still doing the work, right?
The client's doing the work when fetching requests from that origin. So it only looks at the subset of dictionaries that came from that given origin. And to be fair, it's scoped by site. So the site and origin combined as far as partitioning for the dictionaries.
Martin, I'm wondering if you want to maybe have a think about that, and if you think there's something there open an issue. Okay, have a think about it. Any other discussion? We're actually doing pretty well on time. So if there are any more things we want to talk about here, we've got the time. I'm not seeing it. So thank you, Patrick. That's a great update. It sounds like we're making good progress.
Awesome, thanks.
And I look forward to seeing more of the results as you guys are doing some deployment. Kazuho is next. You've got slides for that, right? Yeah.
Kazuho, do you want to present your own slides? Or you want me to?
Okay. So this is the HTTP3 on streams.
Thank you. So we had a discussion at the quick working group, and reflecting that, we have added more slides, more information, the feedbacks. So thank you for all of them. And this time I'm presenting with co-presenting with Lucas, so I have less need to speak. Next, please. So let's recap. Quick is a huge success, as we know, and we are seeing broad adoption. Next, please. But TCP continues to be used, at least as a fallback. And there are so many examples. HTTP2 being the most prominent one, but mock web transport, mask DNS, there are all the other protocols that are built on Quick and TCP. Next, please. And HTTP3 projects will continue to want a TCP fallback.
Yeah, so, any masks enthusiasts in the room will be familiar with the various protocols we support tunneling over HTTP. Some of those really benefit from datagrams, properly and reliable flows. Other things just want to do loads of multiplexing. So to be able to have one connection to your proxy and shove a load of different stuff over it. So the features of Quick, unreliable streams that don't block each other, reliable streams that don't block each other, and datagrams, makes sense to start a mask proxy using Quick and HTTP3. But we know some users can't use such services for whatever reasons, whether it be a network issue or something else. And they want to increase their reachability, say, or their availability. So a fallback option is needed. But you didn't start with that. You started with picking out the biggest population of users with the biggest benefit of the performance and everything that Quick can offer. And for a kind of an alternative mode, performance regressions are acceptable. It's often better to be able to reach something even if it's slow and a bit annoying than having complete service availability outages. So from that point on, you would look to maybe add a TCP fallback option. The natural one, because of the way we design Mask, would be to fall back to HTTP2. But for say like a new project that I'm familiar with, that is a completely entirely different software library, a different stack effectively. You're talking TCP, the interactions with your library and its system dependencies or not, any optimizations, etc. You might have already done that if you're not working on a greenfield project, and that's a solved problem. But for people who are trying to ship something new, having now to import a whole load of dependencies and legacy problems, the things that are wrong with Quick. Sorry, nothing wrong with Quick. Freudian slip. Things that are wrong. So I think on the next slide, to get more specific about these things, I'll let Kazuo talk to this one, and then I'll go into a few more things I hate with HTTP2.
Right. So this is the list of all the piles that we have on both HTTP2 and HTTP3. On HTTP2, we have HBAC. On HTTP3, we have QBAC. So the header compression is different. Priorities are applied differently. And Mask has datagrams on HTTP3, but on HTTP2, you have to always use capsule. So there are two ways of sending things. And Web Transport has essentially ported the Quick features onto HTTP2. And as we develop new protocols for Quick and having the need to support TCP as well, we have to do all those repeated work once again and again.
Next slide, please. So one of the things I really hate with H2 is that concurrency is really broken. We had a really fun summer just post Ietf in San Francisco dealing with this, not just we as Cloudflare, but many other cloud operators and anyone, effectively nearly every, no, that's a lie actually. There were a number of implementations that were affected and there were a number that weren't. But effectively what that highlighted is just a brokenness with the design that we had fixed with Quick, right? We came up with something better, a way to vend stream concurrency that avoids all of this stuff. So the problem that we had is that by default, HTTP2 allows unlimited concurrency. If you don't receive a settings frame that states a different value, and this is as a client, right? You're going to be opening request streams. Effectively, you're allowed to open any number, and that creates work and resource commitments on the server side. No clients that are well behaved are stupid enough to try doing that. So they limit themselves to 100, and 100 is like the value of, oh, it's probably sensible to provide at least 100 streams. And that's what they picked because they implement specs by example, not by the requirement text in them. What this means is that any server picking less than 100 breaks the assumption that the client made. In my experience, clients sometimes just don't wait for settings and just YOLO. And that doesn't cause a connection error in H2. In H3, it would. If you blew the concurrency limit because it's designed well, you would close the connection. But in H2, you just reset the stream and carry on. And maybe then you go, oh, you reset too many, it looks dodgy. But that's adding heuristics and kind of, I don't know, stuff that isn't in the spec about behaviors, which causes interop issues and wastes time with people. And the rapid reset attack specifically isn't even anything to do with concurrency limits. You could set 1 and you could still rapidly reset for infinity as a client by just sending 2 frames in succession, like taking 5 bytes and repeat that hundreds of times per single packet. This was discussed back in Prague. I presented at UFMRG if you're more interested in going to the details. But we had a side meeting too, and we discussed some of the possible options for actually fixing this properly. Everyone's got a lid on it now. They address the resource allocation problems related specifically to the rapid reset problem, or they should have. If not, they're probably offline. But like, we can't fix this like being conservative with the number of streams that you can allow a new client to present on you. So everyone's stuck effectively if they want support and interrupt with having to support 100 connections as our requests. So to try and fix this, Martin Thompson wrote a draft to backport the quick model for stream concurrency back to HTTP2. We discussed this in the side meeting. My takeaway from that was there wasn't that much appetite for it. You know, if there was, we probably would have been having an adoption call right now and people would have been actively implementing it or whatever. Part of that was, you know, it's an extension. So yeah, sure, great. The good guys are going to add the extension and the people who don't care will just ignore it. That adds kind of fragmentation already to the what you can do with H2. So if you go on to the next slide. The activation energy, right? So if you are gonna open up the bonnet on your car to change the oil, you might want to do things like change the air filter and other stuff, right? You're gonna do more work, and therefore it might be more attractive to people if we were to bundle a list of changes to fix the rest of the stuff we don't like with H2 to address a known security or availability problem that was rapid reset. What would you want to do? What is your wish list of stuff to fix? So I went away and wrote something called HTTP2++ as a spec, which was my personal one. Mark suggested I open an issue on the HTTP repo to turn that into a list of not requirements, but things that personally I would like. So go and visit that. And this is just a summary of those things. So the first one, better stream concurrency control. Yep. Remove server push. You know, this has been a long thing in the Ietf. Maybe that's never feasible, but that's something I would like to do because it's code that's just wasted. Priorities has already been mentioned. We've deprecated that. Guess what? That's a setting. That's an extension. That's something you need to support both with now already in H2. We have things related to the extended connect. If you remember, we had a WebSockets discovery session and presented ideas how we could fix that. Yet again, not much appetite just to point fix that one. That sucked, whatever. We have this kind of H2 specific encoding of values, which means that frames are of a certain size. They're smaller than the frames you can have in HTTP3 by virtue of quick. So we end up with an impedance between those two things. Any proxy that's trying to convert between stuff now has to do something. And that conversion isn't specified anywhere. So it becomes an implementation matter. That leads on to point 9, which if you need to send really large headers, you have to send continuation frames. And that suck. So yeah, just remove those two because you can just have a larger frame. There's flags. We have these flags on every frame and they're never used by anyone except for very specific cases, not used by any extensions, blah, blah, blah. There's a whole load of stuff. Like you can see it goes off the bottom of the slides. So we're going to the next slide. Do you want to speak to this one, Kazoo?
All right. Right. So some people might think that now that we've done with all the stuff that we want to do with H2, maybe just we can keep H2 running around. But the truth is that people still keep coming up with new ideas to extend HTTP. And then we have to extend HTTP2 and HTTP3. Think about secondary certificates. You know, we adopted it at last Ietf, and it's going to extend HTTP2 once again. And there's also about changing the static compression table, and it applies to HPAC and QPAC. So we are still doing those kind of things. And moreover, these complexities being added is an additional supporting them intermediary requires additional logic because you then have to convert the HTTP2 version of web transport or whatever to HTTP3. You have to do that for mask. So each extension being added requires new conversion logic to be added to the intermediary. So it's just a pain to have H2 and H3 being continuously extended in different ways.
Next slide, please. Oh, no.
Right. So then that is, that all these recognitions raise the question. So TCP UDP supports both IPv4 and v6. You write one code and it works on both. So the question is like, can we do the same for quick, support quick on top of UDP and TCP and write code once and run it everywhere? Next, please. Right, so that's where quick on streams came. The idea is to backport the quick API contract, or specifically the quick streams, onto TCP and run everything on HTTP3. Next, please.
So if you're going to look at trying to provide a way to express quick over reliable streams, that provides the capability layer that Kazuo was talking about. And what I wanted to do is take my wish list of stuff that, everything I hate with H2 is red and says, no, like we can't actually get better stream concurrency with H2 realistically. We can't have no priorities without it being an extension, so it's unrealistic. We can't change the way that settings interactions occur. There's a number of things you just really hard to fix. So HB 2.1, the chairs hate me for saying that. I saw that look of disgust in the side of my eye. But is there enough energy in the room to try and iterate H2 to keep some of its binary wire format, but change some things so it's similar but incompatible? Maybe, we'd have to go through and discuss each of these points one by one and go through, and I'm opinionated, and that could take a long time, and that's fine. That's consensus building. But to the point Kazuo just made, that would add yet another version of HTTP that we would need to translate everything between, which sounds like really painful. But if we look at what the features are that I like and I want, they're already there in HTTP3 by and large. They would just come for free. Apart from removing server push, I lost that battle, and mandating connect, it didn't exist. But maybe there's something we could do clever there, I don't know. And so if we were to try and consider what HTTP3 over quick on streams provides, it's everything that HTTP3 already does. It's not even that it's compatible from an implementation perspective that you could tweak a few things, pick this up and drop it in. It's that feature by feature, all of the mistakes we made in the past, or that we've come to realize are the sharp edges of H2, are already fixed. But I don't want to waste time trying to relitigate some of those choices we made that might be different and might require even more work and implementation to convert between the two. Next slide.
Right. So what should be our goals or non-goals? We think that the goals should be to eliminate the need to develop new things on top of two protocols, as I said, and to run unmodified HTTP3 on top of quick on streams, and to eliminate the need to deploy two HTTP versions. And that could come immediately when you control both sides. I mean, if you own your own client and it's only the one that you are talking to, then you can just use quick on streams and just use HTTP3. You no longer need HTTP2 as a fallback. And the other goal is that we want to reuse existing quick and HTTP3 implementations. That's by doing so, we reduce the work or the attack surface, even though we create a new variant. And the final bullet point is that for people who want to optimize for the underlying transport, we could always expose the properties like, oh, this is unreliable transport, or this is like TCP. And then those applications can optimize. And on the other hand, the non-goals have been that we don't want to spend optimizing TCP or optimizing quick frames, because quick over UDP works in most cases, and we believe that, or we know that it performs better. So quick on streams is solely a fallback. Next, please. So the design of draft 00 looks like this. We have a new output for HTTP3 on stream. So maybe it could be H3, I don't know, but let's keep it in the bike shell. And we send a minimum set of quick VM frames on top of TCP and TLS directly, and they are only stream related or datagram frames. There are no ARC frames because ARCs are implicit, and there's no connection ID or those things because the connection is managed by TCP. And the transport parameters are exchanged using the first frame called JS transport parameters. And the minimum maximum frame size is 16 kilobytes. I mean, for example, you can send stream frames as large as 16 kilobytes because that's the record size of the TLS. And for what's worth, I was able to create a POC working for Quickly, our quick stack, in half a day. And it took another half day to use that in the H2 HTTP3 stack. So it certainly depends on each person or each stack, but for me, it was very trivial to implement HTTP3 on streams. Next, please. So people have raised concerns, and I think they are valid. So let's go one by one. The first concern that I want to discuss is that there are application layer protocols going to suffer if they are assuming UDP because it's quick and then get TCP. I think that's a valid concern, but the counter argument is that at least for HTTP, we know how to multiplex and run efficient protocols because we have experience in HTTP too. It's only about moving the multiplexing layer from using HTTP 2 frames to quick frames. So we have that experience. Things might be a bit different if the protocol to be run on top of quick is different. But as we said, we could expose flags much like web transport intends to do. Web transport over HTTP2 intends to do. So we already have the design that we think will work in the web transport working group to handle this problem. And regarding the performance versus HTTP2, basically it's just about changing the frames being used for multiplexing. So we expect that the performance would be comparable to HTTP2. And the next concern was that having yet another way of doing HTTP is adding complexity and exposing us to new security issues. But as I said, we can reuse our quick stack. We can reuse our HTTP3 stack. So it's not like having an entirely new set of stacks that you have to deal individually. So I'd probably argue that the additional attack surface or additional complexity is not that bad. And if we consider the fact that we no longer need to extend HTTP2 differently, we are reducing the attack surface at the same time. So it's on balance. I mean, people might have different opinions regarding how they are balanced, but it's not just a one-side game. And to the next point, the people argue that providing a good fallback reduces the pressure from us pushing people to the quick side or the UDP side. But I mean, it's funny because I agree with that, but we are actually creating fallbacks on TCP. So I think we'd rather just accept the reality and do this because it reduces our pain. And one thing to mention is that quick on streams is never going to be as performant as quick. So there will be always the incentive to move to quick. And I think that's a good thing. So I think this is my final slide. So
Great.
Oh,
is there another slide?
The other slide is going back to the.
All right. So next, please. Yeah. Yes, but yep.
Okay.
Thank you. Questions?
Great, thank you. So we have a queue building, and we have a reasonable amount of time to discuss it. I'd say a good 15 minutes. So first up, Yaroslav.
Hi. That's very, very interesting, brave proposal. I think that though it's unlikely to achieve its goal of allowing applications to run solely on HTTP3 stack today, majority of enterprises block UDP 443 not because they don't know better, but because their proxy firewalls and other enterprise things that do web filtering that perform TLS man in the middle are not capable of processing quick. So they block it to force things back into TCP-based HTTP that they can then inspect and intercept. Now, if you're introducing a new way to send HTTP with new ALPN, then guess what? Those things will still not allow that ALPN to come through. And so to retain service availability for those networks, you would have still to support both versions of HTTP3 and HTTP2 or HTTP 2.1. So with that, I'm not sure if this proposal will solve quick adoption challenge.
Thanks, Yaroslav. And I'm not going to disagree with you there. But to respond specifically, if we take I will call it a bucket list because I think Jana said we'd never solve this in our lifetimes, but maybe I could before I die. Like, if we change the wire image of H2 to do some of the stuff I'm talking, like that would be different. And such middle boxes wouldn't support that either. So I don't want to exist in a world where we're not allowed to iterate ever on H2. We have extensions. We're literally adopting new work to keep iterating on H2. But if we're stuck with all the broken stuff, that's not great. Like, so whether it's H2 that is called H2 in a bit and it looks like quick, or it's H3 and it goes over TCP, those boxes are just going to break the internet if they continue to block stuff because they're too lazy to get with it. If they don't, do they support H2 today? If they did, they realize the benefits of doing some work to allow it. If they don't, they're blocking it already and it's not a problem. I'm aware of middle boxes that have added support for intercepting quick and HTTP3. Great. Some don't. That's completely within their remit. So my concern is it's a completely valid point, but it's unrelated to some of the other quick blocking concerns that we've heard before.
Okay, what I'm trying to say is that even if you deliver this proposal, then the number one goal that you don't have to maintain two stacks is unlikely to be accomplished in near future. And if we focus efforts on making shiny, great, unique applications that show fantastic performance benefits and all other great things about that depend on proper HTTP3, that might push for faster, quick adoption.
Sure. As I said, I'm aware of middle boxes that have already adopted support for Quick's wire image, and to me it seems more likely that fixing H2 with the same wire image would be a faster path to deployment than creating yet another wire image and waiting for those folks to catch up. But that's just my personal opinion. So
let's try and get through the queue. I think we have to resolve everyone.
Cool. All right. So Tommy Pauly speaking as an individual. So even like before this, I've been thinking a lot about how to let clients who have UDP blocked locally still access Quick and UDP generally. The comment I want to make is about like how we think about this, and it actually relates to some of the stuff on the chat about saying, "Oh, this is not quick," etc. I'd like to maybe challenge us to think of it a different way, to think of it more like a proxy. Like we're just going to run Quick over a TCP-based proxy or like a tunnel in order to, bypass the thing that is blocking Quick. Because that's actually something you can do today, and like actually that's how we're currently doing it. We can run connect to UDP on an H2 proxy, and like it has inefficiencies, absolutely, but it lets you do this. It actually lets you access the thing, and you could very simply just say, hey, next to my main server just offers some essentially legacy translation proxy as a way to have everything end to end actually be H3. And we earlier said that for these cases, we are always going to be accepting some performance regressions. So maybe it's easier to approach this by saying the model that actually already works is that we can run this over a proxy, and then we want to figure out ways to decrease the level of performance regression of teaching Quick, hey, if I tell Quick that on this path you have a reliable substrate, turn off your level of hacking. If you have an already encrypted substrate, figure out how to turn that off as ways to reduce the harm of performance regressions, but you still have like a baseline that actually works even without that. And I think one of the benefits of doing that approach is that it allows us to still get end-to-end Quick, where we can actually do migration and multipath, such that if we have a session with H3 or whatever it is to the other side, which it could be some other Quick thing that's not H3, maybe I start on a network that's blocking UDP and I have to do this translation over TCP, but then I can migrate and have another path on the same session that's on a different link. And I don't think that's possible if we think of this as a special thing that is quick on streams and is not compatible with end-to-end Quick.
Okay. I'm up next, again, speaking as me, so Mark Nottingham. I like this proposal. We talked about it a lot the other day, Lucas. I think it has a lot of merit in terms of simplifying the stack and unblocking us from doing work in the future and reducing the complexity of how all this interacts. My observation, though, is that it seems like most of the benefits that it brings accrue to implementers and to specifiers. And to most deployments, there's not a strong reason to adopt this. And so, experience has shown that when there's not a strong reason to upgrade a protocol, people don't upgrade. And so I think we have to conclude that there are going to be a lot of HTTP2 deployments out there once we do this. And so that makes me concerned that we could be in a world that is more bifurcated, where there's common HTTP2 deployments and we're not really paying attention to those because all the shiny new stuff is on this. And that makes me a little uncomfortable. Because frankly, a lot of the attention of what we're doing on top of HTTP with things like Mask, and I know people are very enthusiastic about that. There he is. Those are used by a very small set of entities on the internet right now in terms of deployment. And the larger deployments are much more vanilla, and maybe they're okay to just sit there, and maybe they're getting all the value they need, but we still need to pay them attention, I think. And so that's the center of my concern around this, is we need to think carefully about how this is going to play out in deployment. And I think Yaroslav's concern came to that a little bit, because for better or worse, those people are deployments too.
Just to respond to that specific point about deployment, it's non-trivial to create a way to speak quick, right, and have this scalable and robust. We have things like load balancing specs and routing UDP. Like, there's a lot of work beyond turning it on. So being able to focus the feature set on, say, H3 and make that easily deployable for such services where they can just reuse that TLS and TCP infrastructure seems of a benefit to me, at least.
So to respond to your response, I agree, and I think that is one possible future. And so I'm super interested in things like, is somebody going to do the Apache module for this, for example? And is it going to get that deployment where I can deploy it on my little tiny $5 a month cloud server? Then I think that's much more interesting if there's a natural upgrade path. But we shouldn't assume that that code's going to get written and those people are going to do those upgrades.
Alan Frindell, Meta. Thank you guys for bringing this work. I think it's really interesting and I'm really in support. I think even just taking a step back, I think the Quick on Streams protocol it's a very valuable protocol that has a lot of use cases, even if you don't think about what it could mean for HTTP. So there's not currently a generic multiplex protocol that runs over TCP. HTTP2 is like the next closest thing, and it really doesn't meet the mark. For example, we have an RPC system internally which runs over TCP, and it uses multiplexing, but it has its own transport stack. If Quick on Streams was available, we would use that and have only one transport stack to support. So I think there's a lot of use cases for this protocol that go beyond what people are maybe thinking about here. So also, like, we've basically decided that what a modern transport interface looks like, and it looks like the interface to Quick. That's what we built in Web Transport. And if you look at Web Transport over HTTP2, it basically is this. It's just less efficient. Again, I'm supportive of this work, and I think that the possibility, like, I know it's not possible for everyone to remove HTTP2 support, but I think it would be likely that we Meta would probably remove HTTP2 support if we move to this.
I'm going to be cutting the queue in 30 seconds, so this is your warning.
Yeah, I think it was on slide 6 that you talked about retrofitting quick flow control to H2. And you sort of observed a couple of things about why that didn't work out. And one of them was there just wasn't enough interest. And I'm concerned that this is adding code to solve a problem of having too much code. And without an incentive to upgrade, we're in this really awkward position, right? So, okay, so Meta upgrades. Great. That's great for Meta. But there's a lot more people using the protocol than them. And if those other people don't have time to invest in the development of an entirely new stack, then we're in a situation where we have more fracturing in the ecosystem, not more. And those of us kind of stuck in the middle just have way more code to maintain, and we're in a situation where we still have to keep HTTP2 alive. and we've got to keep this new thing alive, and we've got HTTP 1.1 on life support as well, and some of us have 0.9 kicking around somewhere as well. So adding more stuff to the pile is not necessarily something I'm enthusiastic about. And this is why it's difficult for me to say this, because I like the design, I like the idea, I like the sort of promise that this has, but I don't think until we have more reason to do it, this is something we should be pursuing. And I think if we were talking about an HTTP 4 where there was some new thing that we wanted to do over TCP, then fine, this is a great basis for that sort of design work. Maybe the mock people want to fall back for TCP, and that's enough justification to do something along these lines. But we wouldn't necessarily do it for HTTP at that point. And that's the sort of thinking that I think we need to be looking at here, much along the same lines as Mark was talking about, and Yaroslav and others. This is like a great idea, but the great idea has a huge activation energy, and I want to make sure that we can justify that.
Dead?
Yeah, the battery's going down.
Oh, here, use this fantastic microphone.
They still won't be able to hear you.
I'll be even briefer. I think this all hinges on what the delta is. If it takes you half a day to kind of put in a mode, I mean, I think it would be interesting for us to see this precisely. And if the answer is no, then that'd be good.
David Skenazy, quick enthusiast. So +1 to everything MT said. I was much more opposed to this in the quick session, and then we had lunch, and now I kind of understand better. And I think I've kind of distilled our disagreement to fundamental assumptions, which are, if this allows you to get rid of HTTP2, then it makes a lot of sense. If you control your client app and your server, you switch from this and then you forget about HTTP2, this makes your life better. But if you're a browser or a cloud provider, you're going to need to keep HTTP2 support pretty much forever. And this adds something on that list. Another assumption is if you think that there will be a lot of folks building new protocols over quick in the near future. I don't know if that's true, because as opposed to people building new protocols over HTTP semantics or even over web transport, which gives you that indirection layer for almost free. So totally see what I think will be might be the hard part for you is incentives, because for this to be useful to a CDN, you need browsers to implement it, but it doesn't seem to be solving a problem for browsers. So I'm not saying this is an official position of any browser, but we'd have to talk through what helps, what the browser gets out of it.
So I'm going to interject quickly. You know how I said we had plenty of time? This is obviously something that we're not going to resolve today. So let's keep the comments brief, keep the discussion going, but let's get through the queue pretty briskly.
Sounds good. Eric Kinnear, Apple. I did start out very dubious about this in Quick, and we've since had some good conversations that are starting to change my mind. I think tunneling Quick is really nice, but you still need to be better than H2 in order to get there. So I love the idea that migration and multipath could be happy, and that would be an awesome thing. But I think we need to not say, oh, these are going to be people who are already in this really, really sad bucket, and so we should just make it terrible, because they're just going to keep using H2, and then we're going to have the same pressure to build stuff over H2. So right now we're showing about 4% of connections are in that bucket, which is close to 100 million people, give or take. So that's not nobody. Other than that, just development of a whole new stack here is an interesting question, because in my mind, the real thing that makes or breaks this is, do we think we're going to have to invest in H2 anyway? If we think that in order to fix rapid reset and everything else, we're going to have to do a bunch of work in H2, then we might as well do some other work now so that we don't have to keep having that long tail, and H2 is always going to be around and we'll always have to have it. If we don't think that we're going to need to do that and H2 is already dead and we can ignore it, then this conversation is moot. But also, what are we doing in mock and web transport and everywhere else, since we're not ignoring it?
Kyle, I think I'm very sympathetic to the problem here. I think it's a lot more compelling for the case where you have a like non-general purpose HTTP web browser case where you have like a new protocol that's talking directly from client to server, and you just want something that works in a case where like UDP is blocked on a network. The case where you have like a middle box that's blocking things, like I'm not sure there's that compelling of a use case, because if a middle box is going to like upgrade to support this, it probably be fine to supporting quick. The one thing I want to add as well is I think there's kind of a similar problem at the TLS layer where someone builds out a quick stack that they're using for most of their traffic with really nice features like requiring TLS 1.3, but then they have a fallback stack that uses something completely other implementation that doesn't have those properties, might even support like TLS 1.0 because people are just caring about that. It makes it really difficult to make an argument for the security properties. So I think we should be careful that we don't like completely leave out the TLS layer as like that part is still different, and find ways to encourage or mandate using the same exact TLS stack with the minimal set of differences that you can have.
Mike
Bishop, I feel like we really should learn some lessons from the last time we successfully deprecated an HTTP version. Like as mentioned, we still have 0.9 around, a little bit of it. I love the idea of this for a brand new protocol that is going to build over quick, but knows they need a TCP fallback. I would love there to be a dock in the transport area that we could say, okay, just shim this in, keep the same interface, you have your TCP fallback. I'm very hesitant about trying to put HTTP over this because I feel like as hopefully we get like 90+ % code reuse and just branch between the different paths that we already have to support this. But I'm concerned that may not be the case as you try and iron out all the edge conditions that you would need for shipping and not just a proof of concept. So I see some promise here. I'm not sure that HTTP is the first place to do this.
Ted.
Ted Hardy, it's really hard to follow somebody as brutal as that. That was scary. Could you show slide 10, please? I actually agree with Mike on one thing, and that is that I think if you take this as a what if there were a transport protocol with the understanding that it's not a new transport, it has to run over one of the ones that gets through firewalls, but it could run over either one, UDP or TCP, and have similar characteristics, that would in fact get you a critical piece to getting here. My concern at the moment is you have HTTP3 or new protocol called X running on top of these things where they don't give you the same things when run over UDP and TCP TLS. They're just sufficiently different below the API of HTTP3 that I don't think you're going to successfully unify them at the API without doing something like he's talking about and having a shim. I think Tommy's shim is cheap and easy, and it works today. If you absolutely need something, you run a on-box protocol, an on-box proxy that lets you run connect UDP. And the delta between how well that's going to do and the activation energy to get what Mike is talking about is enormous. Realistically, we should live in an internet where introducing a new transport doesn't have to run over UDP or TCP, but that's not the internet we've run in for a very, very long time. We have to deal with the ossification we've got. And I'm very concerned that if you try and run what you want to run with sufficiently different behaviors for TCP in order to avoid this API problem, that the ossified internet is just going to kill you anyway. You're running on top of TCP, but not in a TCP-like way, and that's going to result in you getting killed. Now it's speculative, right? It's speculative, like guessing when people are going to stop blocking UDP. So it's not really worth going down there. But I just wanted to articulate that I think the problem you actually are trying to deal with is the problem of how do I deploy a new transport on the internet And while we don't have deprecation experience for HTTP, we do have experience that says if you want a new transport on the internet, you run it over UDP.
Ted, can I ask you a clarification question about using TCP but not using it in the way that people are familiar with? Can you just expand on that?
So if you're running a proxy that's not sorry, if you're running a firewall that's not a simple block this port firewall, but is doing packet train analysis or more advanced things, something that looks sufficiently different from known traffic for a protocol will get blocked, even if it's on a known port, because it doesn't have, say, this is going to an HTTP port, but it's not doing request response in a way that the firewall is going to recognize as appropriate. So if you get far enough outside the window to get where you are here, I worry those boxes, which are what have ossified us into this problem, are just going to start cutting you off anyway. And I don't have evidence to show you that that would happen, but it does concern me.
I completely agree with that, and I think that's what prevents us from being able to extend or enhance the H2 wire image and fix any of those things. So I think we agreed.
Right. Last up, Alex.
Alex, does this work? Yeah. Alex Shanahowski, Google. I have a few thoughts here, but I'm going to elide most of them. My first thought is that if we take it as sort of granted that Quick on Streams is going to make it out there, because there are protocols like we've been discussing in this week, like SSH3, which some people think shouldn't be based on top of an HTTP semantics, but probably still wants a TCP fallback. That clearly is a way to do this. And if that gets adoption, then we sort of find ourselves here in the HTTP group in a really funny position of, cool, the underlying substrate which makes this possible is already going to exist. What's going to stop someone from defining the ALPN to make this work and have it work? Like, I think one of the things that we've been discussing in hallway sessions about this area of things is that a key metric for success for HTTP3 on Quick on Streams would be if it's almost trivial for users of H2 to migrate. And I think that also changes the calculus. So while I'm totally happy that we might walk away with the session with a not yet, let's maybe get some deployment data, I think that we shouldn't necessarily close the door on this discussion if we do in fact get the data to show that A, this works, and B, it's as easy as we think it's going to be. Because a lot of the things that we've been talking about here they're real concerns, but they're all hypothetical. And I don't want to say that any of them are not real, but I do want to get the deployment data to know if we have to care and how much.
Okay, thank you, and thank you, Kazuho and Lucas. So, Chair head on. I think this is a bigger discussion in a couple of different ways. One is that we've never done a new version of HTTP without a bigger community discussion. I don't think we can just do a call for adoption on this tomorrow and see how she goes. I don't know that requires a BOF. We'll talk to our ADs and so forth, but there needs to be more of a hurdle than just normal adoption for this for the working group. And second, I think this is part of a bigger discussion about how we maintain and evolve the protocol. There's a lot of this is one way we could do that, but I think there are a lot of different aspects to this that we as a community would really benefit from having more discussion of. In the back of my mind, I'm thinking maybe there's a bigger discussion at the HTTP workshop about that issue, because we have more implementers in that room, and that might be helpful. So thank you very, very much.
And I just want to say we had a side meeting this week. We had a great discussion in Quick. We've got another one here. I really want to thank everyone for their different opinions and the way we had a really respectful conversation on that.
Fantastic.
So thank you.
All right. Thank you. Kazuho. Yep. Once again, and sorry, can we compress on time if possible?
Yes.
Thank you.
Let's.
Oh no.
No, yes.
No, it's meeting materials.
Data tracker issues.
No?
Yeah.
Because it was in the other session, or probably it wasn't synchronized.
It's showing up on slides, but it's not allowing me to share.
That's quite a quick refresh documents, maybe.
I did.
Can you get it and then project from your screen, maybe?
Yeah,
Yes.
Minako's not.
We'll be at the end of the session by the time we resolve it. I'm afraid that's the problem.
Rich, do you have the slides?
Why is Rich? Are you in the room?
Yeah, just now.
Oh.
You have.
He's trying to see if it works for him.
Thank you.
Oh, I don't. No, it's not there.
Let me.
That was.
I let him.
Well, we should talk about that.
I'm not in the full client. Are you in the full client?
I'm in the full client. Yeah.
Yeah, so I can't show. No, you need to share the screen.
Okay.
So you can't do that from this client.
And where can I find the?
It is in the material. So if you go in the folder, it knows it's there.
Okay.
No, refresh. Nope.
I can start if you want.
Can you just speak to?
Yeah.
I'm gonna need to leave and come back.
Go ahead and start.
Right. So this is a proposal about doing the reverse HTTP thing. So typically, HTTP clients connect to HTTP servers, but sometimes there's a firewall in front of the HTTP server that blocks HTTP clients from connecting to the HTTP server. And in those deployments, we often use something called reverse tunneling or reverse HTTP that lets the HTTP server connect to the HTTP client at the TCP level, and then let the HTTP client send the requests. So the connection is going in reverse direction, and it's called reverse HTTP or reverse tunneling. In the previous IETF session, Ben Schwartz presented their way of doing this, and it was based on TLS. Basically, the HTTP server connects to the HTTP client using TLS, and it uses a special output to indicate that the connection is going in reverse. Wonderful.
Which page do you want me to be on?
Next, maybe 3 or 4 down. Right, this one. Thank you. Wonderful. Thanks so much. So, and the HTTP server's identity is provided as a client cert to the HTTP client. And once the handshake is done, unmodified HTTP is used, with the TCP server being the HTTP client. Next, please. Oh, yep. Up. Yeah, this one. Thank you. So there was some feedback from Ietf in the previous meeting, and one was that some people, me, had the distaste against exchanging the tunnel parameters using TLS handshake because it seemed to me like it's too inflexible, especially for the large CDN deployments, because the identity or the scope of each tunnel is being is communicated using the SNI or the CERT or the origin frame, and it was considered too inflexible. And the other desire that was raised was that we want to tunnel something other than HTTP as well. Next, please. So this is the new proposal that I have. Ben helped me phrase out my things, but unfortunately, we couldn't come up with a converged proposal. The fault is on me having the desire to have one specific way. So the fault is entirely on me. And this is the new protocol. So basically, the idea is to use HTTP to establish reverse tunnel instead of using TLS. We use extended connect. Next, please. So first, the HTTP server initiates a TLS handshake, and an ordinary open is used. HTTP servers don't need to authenticate themselves using TLS certificates. It could use basic auth, for example. Next, please. And once the connection is established, the HTTP server sends a extended connect request. For the sake of readability, I'm using HTTP 1.1. So as you can see, it's extended connect, and there's the upgrade token that says do the HTTP in reverse direction. And in this example, we are using basic authentication. And then HTTP client says, hey, I'm ready to switch the protocols. And then the HTTP client starts sending the request to the server. Next, please. And once the reverse tunnel is established, HTTP request just flows as is. Next, please. So why use the extended connect? It provides us a flexibility. So recall the discussion about connect TCP. The sole point was that the traditional connect method uses the host name and the port of the proxy, as well as if it uses TLS. And it was considered too inflexible. We decided to connect TCP because it uses URI as the end, as a way of specifying the endpoint. It's the same. So, and the other argument, for example, by using URI, we could create reverse service that's only responsible for handling a specific pathway, for example. It could be a specific domain, it could be a specific user, it could be anything. And it's also the case that once we move to HTTP-based design, we can use any authentication scheme. And it makes integrating this to existing infrastructure so much easier because a CDN, for example, they already have HTTP-based APIs that they provide to their customer. We can just integrate this into our existing infrastructure because Extended Connect is also HTTP. And we also build, and because we build on top of HTTP semantics, it makes us easier to evolve. Next, please. So the question is, we use Extended Connect to create a tunnel and then exchange HTTP request. Which HTTP version is being used? Next, please. There are two options, actually. One is to use TLS on top of this tunnel, but the downside is that there's double encryption. And the other option that we prefer is to use HTTP headers to negotiate the HTTP version being used. And there's also already a standard for sending the open, but there's no one for selecting the open. So the client sends H2 or H1, and the client sends selected open instead. Next, please. And this is really easy to implement, and the performance is guaranteed because in the HTTP proxy, we can simply accept the reverse connect request using H1. And once we send one-on-one switching protocols, we can just move the connection state, the TCP level and tail server connection state to the backend connection for the proxy. And then, we are back to the ordinary job of forwarding the request through the tunnel, and we already have the highly optimized path. So this is very easy to implement, and the performance is guaranteed. Next, please. So the next question was like, what about HTTP3? Do we want to support it? Yes. If we want to support it, we can support it easily because we know how to forward UDP datagrams on an established tunnel. We are doing that in Mask, so it's easy. And next about the TCP relay. Next, please. Right. So we could use this for doing TCP relay as well. So let's say that the HTTP server wants to listen for this address 0.0.0.025. It says the extended connect request, and next, please. And then the HTTP client sends 100 continue, indicating that it is waiting for incoming connections. Next, please. And once the HTTP client acting as a TCP relay accepts a new connection, it can send a one-on-one switching protocols with the forwarded header saying that the client IP address is this. Next, please. So this semantics is like accept. You use one tunnel for one TCP connection being read, but there's only an alternative in which we can use the bind semantics, and it will be like creating a tunnel, creating a multiplex tunnel of H2 and H3, and using that to forward each incoming connection. Next, please. So from me, the questions are, does the design look correct? I think there's fair amount of interest in doing this kind of thing. So the question is about the design. And the next question I have is, do we want to support H3 or do we need to support it now? And the final question is, do we need the TCP relay mode? Personally, I'm not that interested, but maybe people have opinions. Thank you.
Thank you, Kazuho, and thank you for doing that so quickly. We do have 2 more presentations scheduled, and we're definitely going to run out of time. So I just ask people right now, are there any immediate reactions in terms of like almost a dispatch style? Yes, we should be looking at working at this area. I have concerns without going too deep into them. Do we have any immediate reactions? Okay, go ahead, Martin.
I'll be brief. I think you need to think about the security model a lot. As a browser, I don't think I could implement this without a lot more work, and the security model is kind of key.
Okay. Martin?
Yeah, I'm definitely interested in this. I have to admit, I don't quite understand how it works in HTTP3, and I'm wondering if we can use bidirectional streams in the other direction. But in the interest of time, let's discuss this later.
And Ben.
Hey, so this proposal is basically like a TCP first version of this, and I think basically that's backwards. We should basically start with HTTP 3, and I think that will sort of give us the right design, and then just like the previous presentation, we can try to come back from that to something that works for TCP. Dispatch-wise, I think we should put together some kind of joint proposal eventually, and I think the HTTP working group is going to have to be involved, but might not be the right home.
Okay, great. All right.
Thank
Thank
you.
you. It sounds like there needs to be more discussion. It sounds like, yeah. Perhaps side meetings or, yeah.
I think Niddy's next. Niddy, do you want to present your own?
Yeah.
Yeah, great. Thank you. Great.
Cool. Okay. Hi, everyone. I'm Nidhi from Google, and I'll be talking about window sizes for Z-standard content encoding. I recently worked on shipping support for Z-standard content encoding in Chromium, and I came across a few issues, which is what prompted this draft. I'll keep this very short, as the draft is also very short. Just to get some quick background out of the way, Z-standard is a data compression scheme designed by Meta 3 years ago. It's a fast, lossless compression algorithm. It provides higher compression ratios than gzip and lower CPU costs than Brotli. So as the diagram shows, the window size indicates the longest back reference that the encoder will emit and provides a guarantee about the minimum memory buffer required to decompress a frame, which is important for decoders to allocate enough memory. In general, larger window size values tend to improve compression ratios, but this is at the cost of increased memory usage. To prevent unreasonable usage of memory, decoders are allowed to reject a compressed frame that requests a memory size beyond the decoder's supported limit. So the RFC had some text recommending decoders to support window sizes up to 8 megabytes, but this is merely a recommendation. So looking at some of the different tools that support Z-standard content encoding, the CLI uses up to 8 megabytes by default, and it can be increased to 128 depending on the flags. Chromium, which recently shipped support in M123, accepts up to 8 megabytes, and curl accepts up to 128 by default. So because there's different defaults being used here, we have seen a small number of interoperability issues already manifesting in the wild. A few developers have filed bugs because their compressed content doesn't decompress properly on Chromium, but which does follow the recommendation. But when they use curl, it decompresses normally, so that causes confusion. The proposal is to change the recommendation for 8 megabytes to be an explicit requirement for the HTTP content encoding token Z standard to mean that the compressed content uses a window size of not more than 8 megabytes. So the text we looked at before would be replaced with something like this. I'd love to hear any feedback about the number we've chosen or anything else as well. And as I mentioned, we have a small but non-zero number of interoperability issues in the wild so far, so we'd like to standardize on a single window size limit before the usage becomes more widespread. We had some discussion on the mailing list, and I'm happy to have any GitHub issues as well, but if we think this is the right approach and this is a really minimal draft, I'm wondering if this is a good starting point for adoption.
Great, thank you very much. So again, we're time constrained, so let's focus on whether we should be working in this area. Martin.
Yeah, Martin Thompson. I think we should go straight to working group last call with this one. It's so small, we should just do it. And that it was just a bug. And so we should thank these fine people for fixing the bug for us and make sure there's an RSC with that promptly.
Thank you. Eric.
Eric Kinnear, Apple. I would actually second that. Yeah, I would say thank you for doing this. As we're looking at implementing Z standard for Safari and Apple platforms, there's no way that we're going to use 128 megs. We just can't. So we need a smaller number. Somewhere in the 4 to 8 meg works. 8 megs is what everybody else seems to be happy with. That also works for us. So please ship it.
Okay. All right. It sounds like we know what we need to do next then. Yes. Thank you very much, Nidhi. That was very helpful.
Okay.
Okay, and finally, we have a presentation that is, we're talking about it here because it's very close to the implementer population here. It's not clear whether we'd adopt something in this working group, but we wanted to talk about it here. So, David, go ahead.
Thanks. Hopefully the slides work. Oh, okay. All right. Hi, everyone. So this presentation is going to be about a topic that got a little bit controversial over the last year of IPv6 linked local addresses in URIs. And my main goal here is to kind of go through the history of like what happened, because I think because this topic stretches between HTTP and IPv6, not everyone had the full picture. And so I want to kind of tell the history and then have a proposal for going forward. But it is Friday, and this is the last talk of the session, and I didn't have time to make slides, so I asked Gemini AI to make slides for me. But yeah.
This is what happens when slides are submitted very late in the process. You got it? No?
All right, they're still figuring out the slides. There was kind of a warning at the bottom of the page about possible inaccuracies in the results. I didn't have time to check them, so there might be some things wrong there. But please don't take the slides as me saying that the topic is light. There was some real things that we need to address, but yeah,
we're
just
working on it. We're working on it. No. If only there were an app.
Don't open it up. It's more fun if I do it in order.
They don't give us HDMI anymore, so.
Da, 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 da.
I think you're gonna need to start talking.
All right. So, quick primer on IPv6, because not everyone in Httpbis knows all the intricate details of IPv6. So, has longer addresses that have colons in them. That's great and all, but in particular, IPv6 linked local addresses have an interesting property that they have a scope identifier. So that's a name that's slightly unclear, but conceptually what it is an interface identifier. So if you have a machine that has multiple interfaces, say your phone with cell and Wi-Fi, then, yes, all right. This is what an IPv6 address looks like. Can you make it a bit bigger? Or do we?
That's Ted.
Oh, it's Ted. Thanks, Ted. Ted, can you make it a bit bigger? It's all right. So, and you put the scope identifier kind of at the end of the address. But the issue is that URIs don't have a way to encode the end of the address, which is the %0 there, which is kind of the interface name for URS. And then the issue is you need to pass that into the socket when you call connect later. Next slide, please. So let's talk about use cases. This draft is like generic to all of URI-based protocols, but I'm just kind of going to speak about browsers because that's what we're most familiar with here, and it's a good example. So I have this friend that goes camping with his printer. I don't know why, but there's no router out there when we're camping, and so you plug your machine, you use your lightning bolt cable to plug into your printer, and you want to be able to print. And that also applies to any case where you have two phones talking to each other when you're outside of a home. And that's kind of what I want to focus on, is having the cases like this work in a browser and then more generically. Next slide, please. So this works today for ping. So you just type ping in your address. GetOutterInfo actually handles that properly. It gets the zone identifier into your struct sockadder in6, and you can talk to your computer on the other side. I love that when you ask for computers in Google's AI, you get something that looks like another brand I know. Next slide, please. So we realized that there was a problem. we put the best IETF minds on solving it, and they had a great idea, which was, why don't we put the zone identifier into the URI? Next slide, please. So this was back in 2012, 2013, and led to the creation of the esteemed RFC 6874. It happened in the 6-man working group, and of course, because this is IETF and you can't have nice things, we ended up with %25 down there because we percent encoded the percent sign. Great, gorgeous. Next slide, please. The issue is kind of that RFC was kind of written from the aspect of ping. And like for ping, this just works. It's really easy. When you just get a host, you get a string, you pass that to get our info, you pass it to the socket. Browsers are much more complex. So this room knows quite a bit about that. So they work on the origin model, which contains the host name, and then do a whole bunch of stuff with the origin. There's cores, which is complicated security stuff. It interacts with the HTTP cache. It's also in links. And importantly, it is sent over the wire. And so now we have this problem where this zone identifier has only local meaning to the host, is entangled in all these things where in some cases it makes perfect sense to have it, in some it doesn't. So implementing this in the browser becomes way more tricky than it does in ping, and it's not even clear if you can really get it to work nicely. Next slide. Because of this, the implementation of this RFC was somewhat limited. I'm told an old version of IE actually supported this, but that was I'm told that was a bug, that they didn't do it intentionally. As you recognize, the CUPS protocol wanted to do this, but they went with a different format from an earlier draft, and this part is actually not AI generated. This is a real thing. Gorgeous. All right, next slide. But why is this all super complicated? There are two URI specifications. So the one on the left here, as you can clearly see, is RFC 3986, which was developed by the IETF a while back, and that's the one that was updated by 6874 that we just talked about. And on the right, you clearly have the what working group URL living specification. I won't go into detail of why that happened, but the what working group forked the IETF spec and had their own. And to this day, this is the one that browsers use. So you kind of have a weird situation where the one on the left is authoritative for many URIs, but not at all on the web. And this one is there. And there was a request to add scope by zone identifiers to the what working group URL spec. And due to the reasons I kind of alluded to earlier, was deemed kind of too complicated and has with security risks. So they explicitly decided not to do it and added a line to their specs saying we intentionally don't allow these. Next slide, please. So quickly, two more proposals that happened in this space. So the one on the left is draft RFC, I'm forgetting the number, the one that we did before, BIS, where folks were trying to solve the problems from the older one, like it wasn't %25, it said about sending it over the wire, but similarly, it didn't fully address all of the browser concerns, and that was kind of realized a bit late in the game when it went through like IETF last call and got review from the HTTP working group. And as of yesterday, the responsible ADs marked kind of that document as, I think, abandoned is the term. And Brian Carpenter has a new proposal on the right that focuses on user interfaces, where his idea was, let's not try to add it to the URI and instead require that any application that makes use of IPv6 addresses directly allow zone identifiers. But he does mention that this doesn't really work for browsers because you would have, again, of all the complexities we talked about. Next slide, please. All right, so what am I proposing here? So first, I think we take RFC 6874 and we obsolete it. It was a reasonable attempt, but like it hasn't been implemented, and I think we can just mark it as historic. Next slide, please. But then going back to what we're trying to do, we're trying to have connectivity, local only connectivity work. That's kind of the goal. These two devices should be able to communicate without requiring some addressing infrastructure like a router or anything. Next slide, please. But luckily, the folks of Ietf have had great ideas. So we have this concept called MDNS, where similar to how IPv6 allows you to have link local addresses without any infrastructure, this allows you to get names without any infrastructure. So it uses multicast DNS to exchange and to be able to discover the IP address. Next slide, please. Yeah, if you want to go even more printer galaxy brain, it's important to, there's a note in there about how the name should be unique, and that way you can avoid collisions, making your life really easy. And that gives you a nice property, because like if you base your name on like the serial number of your printer, you can put a QR code on it that you scan with any device, and boom, you're inside the web page for it. Great, easy. Yeah. Yep. Next slide, please. I think we're close to done. Of course, web security is hard, and this is what it looks like. So for all this to work well, like all of this is completely insecure, and that's kind of a known fact. Same as, you know, web browsing to 1918 space. We have some considerations in the document. There are some proposals for fixing this, but they're not, I'm considering it out of scope for this document. I'm just trying to resolve kind of a specific issue of being able to communicate with these devices. So the idea becomes, instead of focusing on IPv6 linked local addresses and you putting those in your browser, we say, like, have your device that you're trying to talk to, like your printer, advertise its name, and we can just put that in the browser. That actually works today. The browsers don't need to do anything about it because that's handled by the DNS library underneath in the OS. Next slide, please. All right, and that's all I have. Does anyone have any questions?
Okay. So we're actually at time. For the working group's benefit, I think, you know, we're not considering adopting anything here right now. This is more of the nature of a community discussion. If you'd like to participate in that discussion, please stay in the room. I think we can go over time. And I'd ask especially the HTTP folks, I think it'd be great if you're part of that discussion, but you know, we're not going to do any official work from this point onwards. So let's have a bit of a discussion now within a reasonable amount of time. So Torlis first.
Thanks. Yeah, thank you very much for the work. So yeah, I'm all for, you know, users shouldn't have to know about IPv6 addresses. That's one of the reasons why hopefully, you know, an IPv6 network administrator gets a little bit more money than a user to have to deal with this stuff when DNS isn't working, even including that. And those network administrators also love to use browsers for that because often there isn't anything else. So I don't think we should retire 6874. We should, for users, you know, supersede it in terms of a better. And I think we've seen some evidence in talking to people that browsers don't always support the .local MDNS lookup. So if we figure out where to best do that work, I hope that guy over there has a better idea. Then we should certainly make that, you know, very much mandatory for browsers, but that may not even be Ietf after you've educated us that there are other standards body that may be more important in that respect. When it comes to where then is 6874 relevant, yep, network operators, but I also think in any form of APIs that use RESTconf and any other forms of URLs. And then for, you know, the biggest problem, of course, right, it would be lovely to figure out if there is any particular better way, you know, to fix that origin problem. For something like these zone identifiers. I mean, there is there already, I think, in what WG work for the problem of non-global addresses anyhow. And that stuff is, I think, not including the fact of trying to figure out if there are actually, you know, different zone instances. Let's say the usual RFC 1918 addresses, right? 192.168.1.1 is my router. I changed my SSID. I have the same IP address. And why the heck am I seeing all the graphic from another router on this router, right? So this isn't restricted to these IPv6 addresses. We have the problem in other spaces as well. So for whatever, you know, you folks in WhatWG or so are doing, I think we should be happy to help figuring out the right thing to do and include those zoned addresses in there, even if it means, well, it's hard, but doesn't mean it has to be, you know, standardized and adopted, but what is the right way to deal with these addresses, right? But yeah, they shouldn't be used by users, right? So please don't take them to the camping ground.
Thank you, Torlis.
Stuart.
Thank you. I know we're over time, so I'll be brief. I stood up because I have a request for everybody in this room to see if you think this is a useful problem, and if so, give us some guidance on how to solve it. I'll quickly start. David made a little private joke. I go to Burning Man. One of my contributions is I take a wireless battery-powered dye sublimation printer that makes little 4x6-inch postcards, and anybody who's got pictures on their phone or their camera can come up and make a postcard, which they can mail to family and friends. There is actually a post office at Burning Man. It is the only US zip code that only exists for 1 week a year. And about 10 years ago, I was doing some stuff at home, and it's very common for home gateways and printers and things to have a little embedded web server, and that is the universal UI, so you don't have to install an iPhone app or an Android app. Any platform that has a web browser can connect to my laser printer over the network and see the ink level, so I know when it's time to buy a new toner cartridge. And this to me seems very natural and good. I really don't want to have 20 different apps on my phone for all the devices in my home. I'd rather just have one app, the web browser. And I can type 192.168 something something to connect to my printer, and that works. Or link local 192.169.254. But when I tried to do it with V6, it gave an error. So I talked to the browser team at Apple and said, oh, you need to support the % interface on the end of link local. And they said, oh yeah, that's a reasonable idea. And I thought it was just a bug fix. And they said, but there isn't actually an RFC that says, like, are you supposed to % encode the % or not? And that's ambiguous. And we don't want to just do our own thing and be different from everybody else. So tell us again whether it's an RFC. So I thought, oh, well, that's really easy. It's just a bug fix, right? That'll be uncontroversial. And I worked with Bob, and we made an RFC. I didn't like % escaping the %, but agreement is better than, you don't always get what you want, but at least if we all agree. So I thought that was done, and I went back to the browser team at Apple, and they said, no. And I said, no, but you just said the problem was lack of an RFC, and we did that. And they said, no, we're not doing it anyway. And that was when I went, I don't understand what's going on here, because this seems like a reasonable request. I just want to check the ink levels on my printer. I am learning more about the enormous complexity inside a web browser that is not the same as an SSH client or something. Now, David has proposed, I think, a really good idea, which is let's use .local multicast DNS. And I would hesitate to propose that myself because that seems a little bit self-serving. But after 10 years of sort of trying to push this rock uphill, I think I reluctantly admit that, maybe that is the right way to do this. So one way or another, I think using the web browser for local communication, it is not just for buying shoes from Amazon. I think the web browser has much broader use than that. And I want to be able to use it within my home to communicate with devices as easily as I use it to communicate with something on the other side of the planet.
Awesome. Thank you, Stuart.
Ted Hardy, basically, from a dispatch point of view, I think this needs to go to either a BOF or a short working group, because it turns out there are people who use the current syntax, and they use the current syntax for addressing specific interfaces in network management and other contexts, so you can't deprecate it. And identifying when it is that you can and can't use it needs at least a document and not the hallucinations of Gemini, although they were very amusing. And
just to be clear, there's a draft. I guess we skipped the first slide with the hiccups.
Yeah, so I do think that this needs some actual work to say, in this particular context, because of these things, this is no longer permitted, and basically align the URI what working group spec with ours with an applicability statement, and in other contexts it is permitted and why. But I think it can't be done here because you have to balance the different use cases, and some of them are outside this working group.
Okay, we are now getting people in the back of the room tapping their watches meaningfully. So we're going to go through the queue very quickly. Ben.
Hi, I want to solve this. I'm very excited to see energy about solving this. I think this draft is extremely insecure and is basically like a million different kinds of exploit waiting to happen. It is less secure than insecure HTTP. And I really think that it's pretty scary. but I really want to solve it. And I think that I want to live in a world where I can scan a QR code off of an IoT device and connect to it securely over the local network based on key material that was in that QR code. And I want to be able to get just like a totally human readable, no garbage domain name for a thing that's on my network and connect to it and have some kind of tofu thing happen where like I've approved it, and if its keying changes, I get a big scary warning. I think that both of those things are within our capabilities, and the world needs them, and we should do them.
Thanks, Ben. And for what it's worth, I would love to solve that security problem, but I'm not signing up to do it myself.
Bob?
Go ahead, Bob.
Bob Hinden, just to reiterate, at least I think there's a real need for this. We're also seeing it in IPv6 environments where there is no v4, there is very little user interface, and they've had to do some really nasty hacks to get around this problem. So there is a real user need for this. And you know, we live for a long time because things could fall back to v4, but that's changing quickly. So we really, I don't care too much how it's solved, but we need a solution.
Right.
Thanks.
And I'll just say very quickly, I do hear a lot of people saying that they want the user needs to be solved here, and I think that's where we're seeing good convergence, which I'm very happy about. The solution though needs to realize that, you know, it's not just an address on the network. It's used in the web stack as part of identity, and that loops in all these other parts of things that causes so much complication. So we need to be very careful of that, and it needs to be whole of Ietf. We need to involve the implementers, and maybe what working group too. So yeah, there's some. I agree with Ted. Something else is needed here. Finally, Martin, very quickly. Martin
Hello,
Durst?
can you hear me?
We can.
Yes, I'm not sure. I just had to switch. I wasn't connected all the time, so maybe this has been said before. I think there are quite a lot of user problems that should be solved. But I would like to say something that I said 1 year ago in Yokohama in a close meeting with, I think it was Bob and Brian and two of the other people, which is that the fact that you can configure an IP4 router with a browser is not something that the browser people did because they thought it's a good thing. It is just something that the router people discovered that you can do with a browser, and they did it, and so it works. But the browser people or the browser ecosystem isn't really that keen on these very special, for them, from their point of view, very special use cases that cost them a lot of kind of special considerations and so on. So that's a point that is very important that the IPv6 people should understand. Thank you.
Great. Thank you very much, Martin. And with that, we need to close, and I believe we need to vacate the room relatively quickly.
Yep.
Thank you.
Ted,
Thanks,
your
everyone,
charter is
for your time.
approved. I said your charter is approved.
Ted, thank you.
I'll reach out afterwards, Ted.
Probably right before maybe.